So, did you hear about in surgery there is that option that you don't just cut, or the surgeon doesn't cut everything in order to do an operation. He just has 2 or 3 holes, okay, and then he has that device, some devices being used to get something that's a little bit small out of your body, and that's it. Sure. Okay. Someone you hear that guy, he's done in the same day. The patient went out and doing his life perfectly and no problems. كده؟ You heard about something like that? بيسموه بالعربي منظار. مناظير. Okay. So what we'll be doing now is something very simple. This is what we call the method of sections. So I have this truss. This is A, B, C, D, E, F, G, H. And I'm telling you I only need the marked members. Yani I'll mark you some members here. I only need these ones. Right? I don't need anything else. I don't need anything else. Right? But there's no need to go and solve all of the cross members. No, I'm not doing that. I'll do what? I'll do what we call a section. This is after getting the reactions. Okay, and I got the reactions already from you. Okay? So I'll do a section, I'll cut a section passing through the members that I need. So in this case, it's these 3 because these are the ones required. Right. Ideally, through how many members do I have? The point here is very simple. When I cut a section, what I actually have is a new free body. Focus now. I made a cut, okay, in members. So before this cut, considering the whole rigid body of the structure as a rigid body, these member forces were internal forces. You agree? So what was external was the loads and the reactions. But now after doing this section, if I redraw this part on its own or this part on its own, and you have the full choice by the way to do it whatever you want. And if I redraw back this thing here, I'll have a force. And here this is called FHG. And here I'll have another force called FHC. And here I have, this is not bad unknown because this is, I didn't do a cut here. I didn't do a cut in the vertical. But I need a cut where? In this horizontal. So I have F, B, C. And I have the other forces that are there. And the reaction is there. Okay. The load is there. The loads. You have the same loads. You get the point? But what's new is what? These guys. What's new is these guys. I forgot to mention to write the dimensions here. This is 15 feet, 15 feet, 15 feet, 15 feet, and this height is 20 feet. Okay? By the way, this dash denotes feet. Okay? So write either FT or write this dash. Okay? Type. So when doing this, I will deal with the section. So you should give, I need to give it a number. This is section 1. So I'll tell you, and this is very important when you solve these problems using this method, to mention what are you looking at. يعني, خلاص, you did the whole structure and you got the reactions. I'm assuming that this step is done. خلاص, I did it for you here. In your case, you will be doing it in an exam or an assignment, whatever. Now, you will tell me, looking at section 1-1, starting from here بقى, we will have equilibrium equations. It's a rigid body like any rigid body. So I have sigma fx equals 0, sigma fy equals 0, sigma moment equals 0. And the trick is to take the moment at the point at which several unknowns will pass in order to get the other unknown. Okay? فهنا مثلا I'll take a moment where, and this is point H, this is B, this is A. Okay? But if I take a moment at B, I will have FHG, FHC as unknowns. But if I take a moment at H, I'm getting rid of these two and I'll get what? This one. Okay? Sigma Fy, I'll get this one. Sigma Fx, I'll get that one. So on. But also we need to get the angle here. So if I call this angle alpha, okay? وعلى فكرة هو برضه is this angle يعني مش فارق كتير. So extending this thing like that. If this angle is alpha, then tan alpha is what? This is alpha. Oh, this is alpha. Tan alpha is what? It's the 20 over the 15, which is 4 over 3. Therefore, sine alpha is 4 over 5. So sine alpha is 3 over 5. So if I simply take sigma moment about H equals 0 equals. Now I'm getting rid of this one, and I'm getting rid of the 30, and I'm even getting rid of the 40. صح? So what will I have? I'll have this 30, this 50, and this FBC. So now I will have this. I'm assuming that this is the positive direction. So acting in the positive direction is what? The 30 times what? The R, which is 20. معايا؟ طيب. برضه in the positive direction is what? The 50 plus the 50 times the perpendicular plus distance, which is what? 15. In the negative direction, I'll have what? The unknown itself, FBC. Okay? Times what? The R. So minus 20 FBC. Therefore, FBC, if somebody gets the number, so 20 times 30 plus 50 times 15 divided by 20. Like in بعد كده I'll do sigma Fy equals 0 equals the vertical component of FHC and the 40 and the reaction together. So I'll have here the 50. Yeah? 7.5, negative 7.5. Negative 7.5? لا أنا وديت دي الناحية الثانية. لا أيوه. Positive 7.5. Positive 7.5 كده. طب أنا عرفت منين إن أنت غلطتي؟
هو الدايركشن بتاعه مش كده.
Because this thing, when it bends like that, we said that what will be down is that here will be tension. What's up will be in compression. Okay? حتى احنا وريت لك I showed you ده eraser. طيب هنا 50 minus 40, or this 50 minus that 40, minus the component of FHC, sine or cosine alpha? Sine or cosine alpha?
X ولا
Vertical. Why? Sine alpha, which is actually 4 over 5. Therefore, FHC is equal to 10, the difference between these two, divided by 4 over 5. It will be 12.5 كيبس. صح؟ طيب after that I do the sigma fx. I got all my forces. Sigma fx equals 0. I got the other, I mean two of the unknowns, I get the third one. So here I get my unknown that's remaining is f hg. I got fbc to be 7.5. Okay? And I have plus 30 minus 30. And I have negative or positive? Positive of the component of this thing. So positive of 12.5 times cosine or sine alpha. Ladies, the vertical was sine. So the horizontal will be cosine. So this is clear with fine. Therefore, FHG will be negative 15. Now these two will cancel. This will be a 7.5 plus 7.5, and I'll send it to the other side. This is negative 15. Okay, that's a compression. Again, we are always assuming that the tension is positive, the compression is negative. And it is very important not to do a mistake in something like that. Why? Because, inshallah, when you go to the design course, you will know that designing a tension member is totally different than a compression member, especially in steel. Okay? Any metallic structure. Because in compression, they can buckle. So the design criteria is totally different. We're designing for something totally different, for two different things. Okay, let's look at what he did. Okay, so the 7.5 is right. 75 is there. HG 75 and come. في حاجة maybe we missed something here. Let's review. So maybe we missed something. Ladies, can you revise me this number, please? 7.5? لا 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 اهي ABC 67.5. Can please somebody do the math again? هو بصراحة his number makes more sense. The order of things لا مش هيبقى 7.5 and 12.5. Okay? His number is correct. So this is 67.5. Okay? This is the HC. You didn't get us the HC? The HC اللي هو ال 10. The HC was the vertical, the one component is 10, the other is 7.5, so it will be 12.5. The HC is correct. However, this thing, because it's affected by the value that we got here, this will be 67.5. فده طبعا يطلع negative 75. Okay? So he's right. Okay? وبرضه we should have stopped and asked ourselves, did our numbers make sense or not? فعلا the numbers didn't make sense when we had the mistake, because there is a difference in order between the loads and what we got as forces. And you cannot have a load of 40 kips and 30 kips and 50 kips, that stuff, and then you have a force of 7.5 and it doesn't make sense at all. Okay? خلاص? طيب. So, let me do this problem at the end. Okay? Let's do this case. But that's a case that could be a little bit more silly. Okay. But in that case, I want you to tell me. Let me show it here. In that case, where should I take my moment? Which is easier? First to take a moment. أول حاجة I'm making this cut. أنا سهل. Shall I look left or right? Left. Shorter, easy. The easier way. By the way, both should give me the same answer. Okay? But it's easier to look left here. Right? Right. That's one thing. Another thing is that type which point shall I start with in terms of taking the moment? خلاص احنا we got the reactions, we got everything. H. Why is that? Because these are two slanted members. If I took a moment here, both will come into my equation, and it will be a very silly one. If I take a moment here, I need to get a component of. By the way, you can take a moment out of your shape. Yeah, you can take a moment. You could have this is my shape, and I take a moment out of it. عادي. Like a point out of it. Okay, no problem. But okay, we said okay, let's take a moment here and get this unknown first. Okay. Then after that, هنا because both of them have components vertically and horizontally, you must have two equations to unknowns. يعني you will have an equation in X having the components of these guys, and another equation in Y have the components of these guys, and you'll solve them simultaneously. Okay, this is why this problem is a little bit of a silly one here. It's not a. يعني هنا برضه he took a you can see he took a moment at a point in the space, and you can see out there solves. Okay. But you can take moments at different points. Right. Now let's talk about another concept I want to introduce to you, which is suppose that I have a situation at which I have several members that will come through my cut. What shall I do? And if I give this thing, this is a very clear example of what we call a K-truss. Okay? Very classical case of something like that. If I take a cut here, or here, or here, or here, anyway, you're cutting through four members. And you're having only three equations. So if I do a cut here, I'm cutting in four members. Okay? Right. And I can cut short. Okay? So let's say that the dimensions here, this is مثلا let's say that the height is doubled, so this is 3 meters, 3 meters, 3 meters each. Okay? So these angles are actually 45, these. All of them. For simplicity. Okay? So, let's assume I'm having load مثلا ايه. Assume I'm having a symmetric case to make things simpler. 20 kilonewton, 20 kilonewton, 20 kilonewton. So the reactions will be 30 kilonewton and 30 kilonewton. Let's give it some characters. A, B, C, D, E, F, G, H, I, J, K, L, M, N. Okay? Now, we agree that having a simple cut through this thing, like that, will have a cut in 4 members. And we said that we know that our maximum will be always somewhere in the middle if you are having a classically symmetric case. Okay? So this is our K-truss. So if I'm having a classically symmetric case, we said that I'm expecting the maximum to be in the middle, so I want to get the ones in the middle. But if I'm taking a cut here, I'm cutting through 4 members. So how can I solve it? What شفت السلايد اللي ورا؟ So yes. So actually it's not just only having a slanted section.
هو ايه الفرق يعني عشان هنا we got to 4 اللي قبل كده we got to 3
Yes. So when we cut through 3, we have 3 equations, 3 unknowns.
ايوه ايوه
But here I'm cutting through 4. But who said that I need all of this stuff? I need these 4. I need these ones, the marked ones. I need these marked ones. ماشي. But I don't necessarily need everything. All over. So I can, instead of having one section, I can have 2 sections. So I cut another section that's curved, in addition to the one that's straight. So I deal with each of the 2 separately. When you solve these problems, you need to be very clear when you solve in your solution. You need to make sure that you write me the right thing. Okay? So if I call this section 1, and you notice that I'm using different colors here because I use different colors in my solution. Because I solve section 1 with a color and section 2 with another color. Okay? So section 1, I solve section 1 to get what? DH and FG. معايا يا جماعة؟ خلاص؟ And then I go back to section 2 to get what? DH and EG. You get the point? Let's do it. Okay. So section 1. If I go section 1, I see what? Everything that's cutting into 1. كده؟ I'm not seeing that. I'm not seeing this K, this part. I'm not seeing it. Okay? I'm seeing FDH, FDE, FEF, and FFG. And from the first place, we didn't require you to get these ones, the vertices. We didn't ask you to get the vertices. But I'm not looking for them. All at all. So I start by, so this is, we said this point is A, and the reaction here is 30. This is a 20. Okay? These are my forces. C, D, B, F. So fastest thing, take a moment at D and get FFG, or take a moment at F and get FDH, you get to the same thing. Then sigma FX, you get the other. Okay? So sigma moment about D equals 0. Equals. Again, this will pass by the point, this is passing by the point, this is passing by the point, they will all not included. It's only this one and that one. That one. Okay? So 30 clockwise is 30 times 3. Counterclockwise is what? FFG times the whole 6. Because this is 6 meters. Okay? And then this is 3 meters, 3 meters, 3 meters. So minus 6 FFG. So this will be FFG is equal to 15 kilometers. Okay? طيب sigma fx equals 0 equals fdh plus 15. That's it. There is no forces in the x, so therefore fdh equals negative 15. I'll go back to my original sheet and write it on them. But this is 15, positive 15, and this is negative 15. Now, doing that, I can simply draw a line and say, خلاص كده I'm done with section 1. I go to section 2. Section 2 is a totally different story. Something else. Because section 2 includes these two members. Then that's the 20, that's the 30. This is, now I know it. This is a tension of 15, and that's a compression of 15. I know the directions. Okay? I know the values. This is F EH, and this is F EG. Again, these angles are all 45s. So simply speaking, if I say sigma fx equals 0, it's equal to plus 15 minus 15 plus FEH sine 45 plus FEG sine 45 Therefore, I reach a conclusion that FEG is equal to negative FEH. They are equal in magnitude, but one of them is tension, the other is compression. Then, sigma Fy in 0 equals the 30 minus 20 and I'll have plus FEH cosine 45 minus FEG cosine 45, and now I'll substitute FEG by negative FEH. But also what I'll have if I reorder my equation will be 10 minus this is minus minus, so it's plus 2 of FEH cosine 45 equals 0. Therefore, FEH is equal to negative 10 over 2 times root 2 over 2. So this is actually negative 5 root 2. Therefore, FEG is negative for that stuff. I'm back substituting هنا بقى. It will be 5 root 2. فهنا you can go around things. Okay? That's if you understand what's happening. If you understand what's happening. When you have some stuff in the assignment, it's like that. You need to focus on it. طيب. Another nice case that I would like to discuss with you is one of the problems here. Okay? Keep this for you, but I'll erase that one because I need to write here. Okay? I can work on this side. I can work on that side. Let's try. Let's see whether it will be captured by my camera or not. والله يعني لا شغالة. Will work إن شاء الله. Let's see. لا مش هينفع. مش هينفع. Okay. Let's work here. نجرب المرة دي. Okay. So, if I'm looking at this truss we are having here, we're having this thing like that, like this. That's 15 feet high. And that's probably 15 feet. Okay, 15 feet probably. This way. It's not the scale, yani. Okay. Probably 15 feet. Now it's changing angles a little bit. This is a little bit more. From a first look, can you tell me whether this thing is determinant or indeterminate? So this is an additional 5 feet here. Whether it's stable or unstable. From just a first look. I'm having only one load. This is AX, AY, that's point A, B, C, this is CY, that's D, this is DY, and that's F and E. Okay? From a first look, can you tell me whether this thing is determinate or indeterminate, whether it's stable or unstable? Are you ready to tell me? Okay. This is 60 kilo. Beep beep. Hello? Look at the truss, look at the thing. Again, going back to the basics. Well, there's not salad back to the basics anymore. Okay? Back to the basics. Back to the fundamentals. What's being determined? What's being indeterminate? Indeterminate is if I have more unknowns than my equations. I have more reactions, so I cannot get it. Right. What's being stable versus unstable? Unstable, we said that we have two kinds of instability. Geometric instability, صح? And we have what? And we have the classical instability, which is having less reactions than the equations. صح? Right. What's my case? What do I have here? That's 15 bar the horizontal distance here. What do I have here? Okay. So it is, you are saying it's indeterminate? Bravo عليكي, which is what? Why do we have a geometric instability here? هي مش قوي بس يعني we're missing a number. There's a missing diagonal here. So this missing diagonal, خلي بالكم. This is a very special case. What's happening here is what? This is externally indeterminate. You're having an additional action. However, there is internally, it's unstable or it's missing one member. So it ends up with what? It ends up with what? There's one more, less, but stable and determinate. But how to بقى do the determinacy thing? I need an additional equation. I have globally, I have sigma fx equals 0, sigma fy equals 0, sigma y equals 0. The easiest thing here, by the way, is to start with the sigma fx of the whole structure. For the whole structure, by the way, I'll solve the whole structure in black. The sections will be in the other colors. Okay? So the whole structure sigma fx equals 0, so ax, so I have 60k minus ax. Therefore ax equal 60. ده أسهل حاجة في الدنيا. Okay, that's the easiest thing to start with. This way. So this is 60k. However, if you try to apply sigma moment or sigma fy at any point, you will not be able to get the vertical action. But we will start with using the advantage that we are having a missing member. We start by using the advantage of having a missing member. So where shall I take my section in order to use this advantage? Take a section where? In the middle, at the area with the missing member. I'm taking a section at the area with the missing member. So let's call it section 1. This section 1 بقى, it will look like what? What will be my unknown? So now I either look this side or that side. زي ما اتفقنا قبل كده. صح؟ The easiest, by the way, you could look wherever you want, yeah. مش فارقة. So if I look at that side, what will be my unknowns? My unknowns will be, I'll draw them here in blue. FE, FBC, صح? And the reaction is an unknown. مش كده؟ صح؟ أهو. So if I look at this part only, ladies, the left hand side part only. برضه هنقول we must write section 1 اهو. اكتب لك section 1 برضه. Okay? So where should I start? Where's my moment? Where should I take my moment? Where should I take my moment? At A? If I take a moment at A, I'll have two unknowns. I'll not start with the moment أصلا. It's not always the case that you will start with the moment. If you just take sigma Fy, you'll get Ay. أهو. Sigma Fy equals 0. It's equal to Ay plus nothing. مفيش حاجة. There's nothing in the vertical direction other than the Ay. There are no forces in the vertical. No loads in the vertical. Therefore, Ay equals 0. 0 is a magic number by the way. Okay? طيب then خلاص يعني I got this one. So AY is equal to 0. After that I solved FFE and FBC. هنا بقى I could start by taking a moment at this point مثلا sigma moment about F equals 0 equals what? هنا the 60, the horizontal action, times the vertical distance, which is 20. And that vertical distance is 20 feet. 20 feet. Okay? So 60 times 20 minus FBC times what? Minus 15 FBC. Therefore, FBC is equal to what? 80 kips. So this is 80k. I'll write it here 80k. بعد كده sigma fx equals 0 equals FFE. Look here, we're looking at this part. So it's plus 60 minus 60. Plus 60 minus 60. Plus FBC, which is 80. Therefore, FFE is negative 80 kips. Negative 80. خلاص بقى اتفك البتاع ده خالص. Now, can you go back? We can go back to our full structure and solve the thing globally. Okay, if I go back, I'm using now the black one. If I go back here and I solve everything, and I take a moment at A, sigma moment, أو بلاش أنا آسف. I'll take a moment at D, sigma moment about D equals 0. I'm here. So I know this guy, but my unknown was what? Cy. So sigma moment at D equals 0. So this is equal to 15 times Cy. Acting with it is 60 times 15. This 60. Acting with them is what? This guy. 60 times 5. Okay? Do you get this? I need you ladies to stop me if you are lost. I need you ladies to stop me if you are lost. Again, I'm taking a moment here. I know the AY is 0, فخلاص it's out of my equation. I know 60 times 15 اهي. CY times 15 اهي. Okay? Acting with them برضو is what? The 60 times 5. Okay? Therefore, CY is equal to, so this thing is 15, goes away this way, and this will be 4. So this will be 20 plus 60, this will be 80, but it's a negative 80 kips. It's going down. Then, sigma Fy with the whole structure equals 0 equals the negative 80 that I have just got plus dy, and there is nothing else, and plus the 0 طبعا, which is AY, and there is no other loss, therefore dy equal 80 kips up. بعد كده بقى if you want to go and solve it with the method of joints, get these ones and these ones, أهلا وسهلا. Okay, let's double check our solution. Here the AX equals 60, AY equals 0, and FBC 80, and the FFE is negative 80, and then he goes and solves the truss using the method of joints. طبعا you can start with any joint, by the way, and you can solve this joint or that joint because these ones are, you know them already. You also can also solve this joint or that joint. Yeah, it's very clear that this joint board will be 80k. Here this guy will be 80k, and this is, if you look at this thing, this see why it came to be now negative 80 going down. So this will be an 80 tension. Okay, can solve the remaining members. Okay, okay, are you lost?